Welcome to another Great Cow BASIC tutorial. This is part 11 for the PIC18FxxQ41 chip family. Today we're going to be looking at I2C. We're going to discover a device that I've got attached up, and we're going to figure out what its address is. We're going to pretend we don't know its address at one point, okay? Great. I'm using a low pin count demo board, and it's this green one on the left, and I'm actually going to be plugging in a display, an I2C display. The layout looks like this. This was done by Chris Roper, good colleague and good friend of mine, and you should be able to copy this, and this is essentially the low pin demo board. Great. Let's have a quick recap of I2C. I'm not going to be covering it in depth. You need to go and do your own research, the ins and outs of I2C, but it uses two connections. They need to be what's called open collector or open drain, and they're pulled up with resistors. There's two lines are SDA, that's the serial data line, and the serial clock line. And those are very common names, SDA, SCL. Typical voltages are specified as 3.3 and 5, although there could be others. Be careful with operating voltages. I'm not going to go any deeper into the rationale for I2C. I'm going to show you how you use it in the context of Great Cow BASIC. So what have I done? I've connected a couple of lines. Let's have a look how I've done it to start. Let's look at the lamp, okay? Let's look at the lamp. Look, it's fallen over. I've created a little voltmeter, look, using an I2C. Look, it's an I2C display, look. And we're going to actually discover what that address is in there. Obviously, I know it, right? But we're going to discover what that is, okay? So I've connected some yellow and blue wires, as you can see in that photograph, in there, to my display. I've connected up a number of very key connectors. They are 1, the ground, 2, VCC, or the supply voltage, 3, the data, and 4, the clock. I always use blue for data, yellow for clock, and so because we're using the serial, I also use the transmit, and we're going to have to select those in using PPSTool because this is a PPS chip. This does not work unless you have set up PPS. Now, some chips don't have PPS, so their ports will be fixed. I've selected these ports here in the blue and yellow as my ports. You may select something different. However, when you make your connections to your I2C devices, and I'm using one device, you could have many devices, hence you need to know its number. It has a unique number on the bus. You need to figure out what that is, and that's what we're going to be doing. So I've got an SCL pulled up with a resistor here. I've got an SDA pulled up with another resistor, and then I've got it connected to my device as shown here. It's very simple. It's not hard. It is not difficult to figure out what the address of this is. I can look on the back of it. It's 0x78. It could be another number. So I'm going to use a discovery program to set up I2C and discover that number. So how do I do that? I do that by using PPS to set up the I2C ports. I'm going to reset up the PPS for the selected US port, the USART port that we have been using, and then set up the I2C. We'll just review the code and see the results on the terminal. Okay. Well, we've had a look at the lab. We know it's connected because it's actually working. Okay, so let's just validate what we're doing. Here it is. It's working. So we're going to discover its device. I've made a little meter, and you can see in the you can see that if I set that to, let me just set that to 0.54. It's a little meter. We've made a little meter. It's good. It's cool. We're going to come back to that later on. Okay, so let's look at the code here and walk that code to see how it all works. Okay, so normal setup. Sorry, there's the top of this code. Normal setup, hash chip, and then we'll specify that chip option explicit is pretty obvious. Then we've got the PPS section. I put the PPS section at the top. You may decide to put it somewhere else. It's self-contained. As you paste it in, it works. Okay, so let's work out how we do that. And if you remember, we use PPSTool. I've opened up PPSTool and I'm going to clear that down. Here's my chip pre-selected, and I'm going to just put my transmit. I need the serial. I'm going to put that in and add that in on RC6 because that's what we had before. Now we're going to add in the SDA. I can find the SDA in here. The SDA is there, and I'm going to put that on port B6. So I select RB6 and add that in. Then I'm going to select the S serial clock line. Serial clock line. And I'm going to put that on B4. Now if I take a copy of that, by pressing copy, I can go back into the editor and paste that in. And that will set up PPS for us, nice and easy. If we go back to PPS for a moment, we can see in PPS that we've selected some ports. They've gone green in the little icon here. We've got a little green one there for the third in from the right, which is what I was using the other day. And I've got these two here. You can select lots more. As you saw, the options on setting up that clock line are pretty vast. Okay, you can select most of the ports. I've happened to select those ones. Back to the code. I've documented what we're doing, so I've added in my SCL and SDA on port B so that it's in the right place. So I've got it documented. And these match up. RB6 is up the top here, is on the SDA, and the RBS is on the wrong one, is it? SDA. I've flipped them around. Let's do it again. It's always good to do things twice. Back into PPSTool. Clear that down. I'll get it right eventually. I'm just reselecting all the parameters. I've just selected and resetting up my serial one. There we go. Copy that in. And there's nothing wrong with doing it twice, is there? Just make sure it's right. Wonderful. So we got the clock on RB6, which is absolutely correct. And we have the data on RB4, and we have the transmit on RC6, and that's what we had the other day. Let's do some code walking. This is the previous setup in terms of all the constants. Let's look at these few here in particular to set up the I2C. You need to specify a number of parameters. You need to specify I2C baud rate. This one happens to be 125. Options are typically 100, 125, 400. This particular chip, we use 125 because that is a clock source that's available to I2C. Other chips may be 100 or 400. You have to just look at the sample code. We re-specify where the data is connected to. It's on I2C is on B4, and so we can see that the data matches up with what we had up here in our code. Where's the data line here? RB4. There we go. It all matches up, and that has to match up. And then we just say that the data line, I2C data line, is an output, and the clock is an output. They are required, so you need to put in 5 lines. The baud rate, where the 2 clock ports are, and the 2 ports need to be output. And the rest of this is just formatting. It does a discovery. It sends an address to every single available address. And it could be in the range of 0 to 255. And it returns back a true or false and puts it on the screen. So let's just see that happen. So if I go out to my desktop, I bring up the terminal. I've got the terminal connected on COM port 8, have I? Let me just bring it up. Probably connected already. It is. It's going to produce a display that looks like this. And that display tells me I've got devices on 78 and 79, which is the write and read addresses. And it absolutely is correct. So let's just make this all happen like magic. Move that out of the way. We're going to program it up. Here we go. It's just programming it in. We will see the terminal flash. I'll just clear that down. And it didn't do it. Do you know why it didn't do it? Because I have this wire disconnected. I'm going to connect that into third on the right, which is our serial port. I disconnected that just to get it out of the way. Okay. Desktop. This is the serial software. I'm just going to press the reset button, and sure enough, it's just done it. So let's just let's not for mystery here. Let's reprogram that and look at the terminal. We'll see it flash up, and it will do it again. There we go. It's just reprogramming it. Wonderful. It's there. If I disconnect the serial, you'll get dashes everywhere, and therefore you can put on this bus 255 different read and write addresses. So we know that on the back of that little GLCD, it's address 78, and sure enough, in the code, when we look at this later on, I'm going to be using the address of 78, and that was the address that we needed. Sometimes you need to use this program with this type of display to understand that your bus is operational. So it's a very useful program, not only to discover the addresses, which you might know, but that the bus is operating, that you've got your pull-up resistors in the right place. This is an important program. Let's go back to PowerPoint. So we wanted to set up the PPS for the I2C and USART. We did that. We set up the I2C. There's only a couple of constants. You have to set up 6 things: baud rates, the ports themselves, and then which direction they're in. We reviewed the results very quickly. We saw the results on the terminal. So I hope you enjoyed that. A very detailed analysis of I2C in terms of how it operates. But tomorrow we'll be looking at EEPROM and showing serial values on the terminal, and I'll throw away the I2C stuff, okay? We will come back to it. We're going to come back to lots of stuff like that later on. Enjoy.